Okay, so all right, so I I created a new post in this subreddit Reddit right here. And the title of this post is called Creating a Moon Base for humans to live in. So like a base on the moon for humans to live in. And basically I try to summarize um I had a very in-depth conversation with ChatGPT about creating a moon base versus creating a moon data center, although both of these things will need electricity to operate and will also generate heat, and that heat has to be radiated somehow. So this one requires electricity, plus the heat needs to be radiated into outer space. This one requires electricity to operate, plus heat needs to be radiated into outer space. So it's just, both of these systems, this system and this system requires electricity and heat to be radiated. And it's just, two things are more difficult to sustain, whereas one thing is more easier to sustain. And so if you wanted to mainly support one thing to sustain, I would just support this aspect to sustain. Mainly focus on this aspect because this aspect will create, um, in the long run, a longer human presence on the moon, which is a good thing. It can also create the aspect of harvesting resources on the planet moon via um, like humans going out and harvesting the resources with tools. It's a lot easier to do that, which will generate returns on investments and producing good results for humanity. For this one, for like a moon data center, you could technically establish a moon data center or a giant moon data center that is also integrated with artificial intelligence and have these and create like autonomous robot vehicles and things like that that will just roam the moon and harvest resources via autonomously harvesting resources. But that's very difficult to do. Not only will that require a lot of electricity, like in the megawatts, like 10 megawatts to, 100 megawatts, or, probably even close to 1 gigawatt. And that's just, I do not, sustaining that in sustaining that amount of electricity on a regular basis is very difficult to do, although it could technically be done via like nuclear reactors. But however, um, with the Moon AI data center, the Moon Artificial Intelligence data center with like the autonomous robots harvesting resources themselves, um, generating 1 gigawatt of electricity could be achievable, as in generating it, but radiating slash expelling that amount of heat generated into space via radiators, that is very difficult to do with 1 gigawatt of electricity, because the radiators are always going to have to be on moon's surface, and so the radiators have to live in environments that have they could face micrometeorite impacts because they're on Moon's surface, and they're going to face um, Moon's natural harmful radiation and from charged particles that will hit the radiators, which can cause electronic damage. Anyways, so regardless of what I just said, this is probably this right here is probably something to not focus on. Instead, focus on this, and a lot of things will be benefited by focusing on this. But anyways, so back to this. Okay, so this is creating a moon base based on the moon for humans to live in. Okay, so a recent post that I made to this subreddit was about establishing a moon data center, in which the recent post that I made is going to be associated with this. Okay, so this was the recent post that I made to Ask Space. Okay, so I said, establishing a moon data center can theoretically be done, by the way. It can theoretically be done, and even after having lengthy conversations with ChatGPT, establishing a moon data center can theoretically be done, by the way. But it's just, the better one would just mainly to be focused on this one right here. A lot easier to do, and plus, you would rather have electricity generated and heat being radiated into outer space by only focusing on one thing. One thing is better, both things are worse. Focus on this. It can theoretically be done, and you can implement a system, radiators, that will allow for heat to be radiated into outer space. However, a moon data center needs so much amount of electricity to be in operation, like 10 megawatts of electricity to be in operation, and the electricity generated to power the moon data center, will also convert and eventually turn into so much heat. And the heat will build up inside the moon data center, and eventually, in order to expel the heat into outer space, the heat will need to be radiated / expelled into outer space via radiators, so that the components do not get too hot. This is why the heat needs to be expelled. And radiators are most likely going to have to exist on Moon's surface. They exist on the surface, and which the radiators are facing potential micrometeorite impacts equals micrometeorite impacts are normal on the moon. They are. And the radiators are constantly facing electronic damage via the moon's natural harmful radiation and from charged particles. And this is why, because of electronic damage via radiation, harmful radiation and charged particles, is one of the reasons why spacecrafts use radiators that are like So in order for spacecrafts and other things to expel heat or to radiate heat into outer space, because that's the only way that they can successfully lose the heat because of a weak atmosphere environment or no atmosphere environment and conduction process, that's the only way that they can lose heat is by radiating it into outer space via radiators. But the radiators are, going to naturally suffer in these environments from electronic damage over time via these things, harmful radiation and charged particles. And so spacecrafts, in order to get rid of the heat that was generated, they have to radiate it into outer space via radiators. But the radiators and things like that have to be hardened, advanced, have to have like some type of very advanced protection measures so that these things do not really harm them that much, destroy the radiators, in which they will face electronic damage. So that's one of the reasons why they have to become more advanced and shielded, hardened radiators. And here's an example. Radiators are exposed to the harsh space environment, extreme temperature swings, intense solar radiation, bad radiation, charged particles from the sun and other things, and vacuum conditions. And over time, it just causes damage to the radiators. Anyways, anyways, that's what the Moon Data Center right here. Anyways, even though a Moon Data Center, it needs electricity to operate, generate electricity, like generate 10 megawatts of electricity, but eventually that electricity is going to turn into excess heat over time, and that heat will build up. And even a Moon Data Center for humans to live in, it also needs electricity to operate, and it also generates excess heat, in which the heat needs to be radiated into outer space via radiators. And it's just, having both of these things, it puts more stress on the system of radiators, but only having one thing, it puts less stress on the systems of radiators. And so the one thing to mainly focus on is this right here, a moon base for humans to live in, because the humans, they can conduct research and things like that to a much more easier degree that requires less technological advancements. And the humans, they can also harvest resources on the moon that requires less technological advancements, whereas for this one, it requires more technological advancements. It requires more electricity usage in terms of like hundreds of megawatts, maybe like 1 gigawatt, because you need very advanced autonomous mining robots, which, apparently is very difficult to sustain. But, this is easier to sustain. And if you can have humans live on the moon for a lengthy time period and harvesting resources on the moon by something like this aspect, then it will generate returns on investments, so that it would be like investors funneling money to these space companies and it will also correlate to a good result that benefits humanity because, of extra resources, things like extra helium and stuff like that. But anyways, they both need electricity and they both generate heat. This is the better one. Keep in mind about the part that the heat can only be expelled into outer space by radiators, and you have conduction process, etc. Hopefully you know what that means. Anyways, after having a lengthy conversation with ChatGPT regarding what should humans focus on implementing first, the moon base for humans to live in or astronauts to live in is the best option. And side note, systems only need to focus on generating electricity to power moon base features and radiating heat into outer space. And it's more sustainable because it does not require that much electricity, whereas this one probably requires more electricity. The moon base for astronauts to live in would look something like this. Okay, so I'm just trying to help you visualize how the moon base would look like. So it would look something like this. I had posted another thing to Reddit. I mean, you can read this in this document. I also talk about well, anyways, I won't talk about those measurement types, but okay, so this is how to visualize the moon base for humans to live in. Okay, so it would look something like this, in which apparently it seems like the best locations to install everything for like a human moon base or a moon data center, but primarily a moon base, is going to be underground on the moon so that there is a roof that covers the moon base, like the regolith layer is on top and it acts as a roof, and the regolith layer acts as a natural, because it exists naturally, a natural shield from regular extreme temperature changes, a shield from asteroid impacts and micrometeorite impacts, and etc. Regolith layer is a natural superior shield to all of these things. But anyways, this is how the moon base would look like. It would look like by visual means. So the moon has a natural gravity measurement of 1.6 meters per second squared, which humans in astronaut suits can live in. However, when humans live in a low gravity measurement environment for a lengthy period of time, it will cause bone loss, muscle mass loss, and that happens naturally. So that's one of the reasons why humans with astronaut suits cannot really stay on the moon for that long, because gravity measurement is extremely low. However, if you were to get gravity measurement to become closer to 9.8 meters per second squared, it does not have to be exactly 9.8 meters per second squared. It could go from 1.6 meters per second squared to like 2 meters per second squared, and that will be a tremendous change on humans with astronaut suits being able to stay up there for a little bit longer and slow the rate for muscle mass loss and bone loss and things like that. So essentially how to have humans with astronaut suits to live in live in an live in an environment with a greater gravity measurement, going from 1.6 meters per second squared to 2 meters per second squared or higher, is this. So a human is, or humans are on a walkway, and the walkway is inside a hollow pipe or a hollow tube. Humans on walkway, right here, humans, and then this blue line is a walkway, plus inside the hollow pipe, plus the walkway is glued to the floor of the hollow pipe, so there's a humans, and then that blue solid line, which is the walkway, humans are on the walkway, and then this red colored thing is the walkway is attached or is glued to the floor of the hollow pipe. So it's kind of like the walkway is the walkway in the since the walkway is glued to the floor of the hollow pipe, the walkway is a part of the hollow pipe because it is glued, and the humans are on the hollow pipe. And then the next thing that happens is that the hollow pipe starts rotating in a 360-degree manner. So like hopefully you know what I mean by rotating the hollow pipe. It starts rotating, and if it and then once the hollow pipe rotates fast enough, and the floor is still glued to the inside of the hollow pipe, and the humans are on the floor, and they're basically all a part of the rotating hollow pipe, it will create artificial gravity. It will create the effects of artificial gravity / a greater gravity measurement. Humans like living in gravity measurements that are closer to 9.8 meters per second squared, to so that they can stay in the moon environment or on the moon planet for longer periods of time. But anyways, hopefully you know what I'm talking about. The pencil color right here is a hollow pipe. The blue pin color equals the walkway and humans on the walkway. And then the red pin color equals walkway is glued to the floor of the hollow pipe. And so now you have everything all being integrated into one system to perhaps create artificial gravity or centrifugal force. And now the next thing you need to do is have rotations, which what the black pin represents. Black pin color equals hollow pipe is rotating with enough rotations per minute for humans to feel the effects of artificial gravity / a greater gravity measurement. And remember, the importance for humans living on the moon in a greater gravity measurement environment is to, well, I guess make walking around on the ground easier and things like that, because you have greater gravity measurement on things on the ground, and also to delay the process of muscle mass loss and bone loss and bone density loss and things like that. So humans will have a much easier time staying on the moon for a longer period of time. But anyways, basically, regarding the aspect of humans living in how to get humans to live in a greater gravity measurement environment that is closer to 9.8 meters per second squared, which would be in here, and the environments in a greater gravity measurement environment is going to be the living, if you can see it right here, is going to be where this icon is, right by the paper right here. The living and sleeping quarters is in a greater gravity measurement environment. The medical quarters are in a greater gravity measurement environment, and the recreational and workout quarters are in a greater gravity measurement environment. And I guess if you want to sustain humans living up there, living on the moon for a longer period of time, to delay the process of muscle mass loss and bone density loss and things like that, then you want the humans and human natural living situations to be in a greater gravity measurement environment. Okay? So that's that. And then, once the humans walk out of the greater gravity measurement environment, they have some type of airlock system that they walk into. And the airlock system that they stay in for temporarily is just for the humans to get slowly accustomed to different gravity measurements, because they're going from a greater gravity measurement environment, which is the hollow tube, walk into the airlock system, it does what it does, and now they're walking into some place with the moon's natural gravity measurement, which is like 1.6 meters per second squared. So the humans went from this, which let's just say this is about 3 meters per second squared airlock system. They get used to something else, and then once they get used to it, then they walk into a 1.6 meters per second squared environment, in which this structure right here, this big black box is just a room that is dug out, and this can be like associated as the main storage room, and it exists in a lower gravity measurement environment, or like moon's natural gravity measurement of 1.6 meters per second squared, in which that has advantages of making things lighter for humans to carry. But this big black box is going to be associated as a storage room for things, like for storing resources that were collected on the moon, or resources that were harvested on the moon, plus a docking station, or a potential docking station for spacecrafts that have landed on the moon, and satellites, and a storage area room for drilling tools and mining tools, and etc. And this is, and primarily, if you want these things to be safe, and you want these things to be safe from the dramatic extreme temperature changes on the moon's surface, and also safe from asteroid strikes and micrometeorite strikes on the moon's surface, and perhaps safe from moon's natural harmful radiation and charged particles, because if those things hit, if these invisible things start hitting certain things in this storage room, then that might cause bad things to happen. And so you just want these structures, if you want them in the most ideal conditions, to be underneath or to be underground on the moon, in which there is a regolith layer, moon soil that acts as a roof that shields all of these things from micrometeorites. That is the most important thing, to shield it from micrometeorites, to shield it from the moon's regular extreme temperature changes, and etc., like charged particles and radiation damage and things like that. Okay, so this is like a baseline to follow. Or hold on. Okay, so basically, if humans want to establish a moon base on the moon for humans to live in, this is what needs to be happen first. Oh, they need to first start delivering the drilling machines and to the moon. Bring all of the infrastructure up there and store it somewhere to eventually build everything and have everything all in one place. Hold on.